Okay, when you're dealing with an absolute value inequality, it's a little bit different. Okay, because there's two different ways to solve it depending on whether you're dealing with a less than or a greater than. And so let's take the case of a less than. Okay, when you're working with a less than, which means your absolute value expression is going to be to the left or to the pointed end of an inequality symbol. Okay, question? Okay. What you need to do is, again, isolate your absolute value expression first. Okay. Once you isolate, so in this case it's already isolated, then what you're going to do is you're going to sandwich the expression. And so what it means by sandwiching is we're going to take this expression that's inside our absolute values and we're going to sandwich it. It's going to be in between what was given, the 7, and the opposite of what was given. So what's the opposite of 7? Negative 7. Okay? So this is how you'll treat, once you isolate the absolute value expression, okay, you're going to sandwich it between the number it was set less than and the opposite of that number. Okay? Less thans become and inequalities. And so the and inequalities are the ones that are kind of combined in between. And now you just solve it as the and compound inequality. Okay? The symbol for inequality I'll use is just equal sign with a slash through it. Okay, so if we solve this as the and inequality, we just isolate the expression containing x in the middle by undoing the operations to all three parts. So that gives us a negative 10 is less than 2x, which is less than 4. Continue to undo. So we can now divide all parts by 2. Whatever you do to one part, you have to do to the other parts, all three. And then just simplify what you have here. And so if I was asking you to write this in inequality notation, your interval notation, your lower limit would be negative 5, your upper limit would be 2. Would there be brackets or parentheses around these? Parentheses, good. Now, if you had to divide by a negative, okay, so I want you to try this one on your own here really quickly. Okay, see if you can solve this absolute value inequality. So if you isolate the expression, it's already isolated. So since it's a less than, it gets sandwiched between the 2, what was given, and the opposite of what was given. And then you just solve it as the and compound inequality. So we subtract a 10 from all parts. Negative 12 is less than negative 4x, which is less than negative 8. Undo or isolate the variable completely by undoing the multiplication. So if we divide by negative 4, we get a positive 3, an x, and a 2. Now I didn't write the inequality symbols because what happens when you multiply or divide by a negative? You have to switch them, flip these inequality symbols. And now if you didn't, okay, so let's say you were solving this and you forgot to do that step. Okay, would it make sense that 3 is less than x, which is less than 2? That doesn't make sense, right? Because if x is greater than 3, it can't be less than 2. So that's inconsistent. So hopefully you can see that inconsistency and then go back and recover what you missed. Okay? But when you are writing your solutions, I always want you to write from like where it would look on a number line, from lowest numbers to the largest. So the 2 is less than a 3, so we need to write it in this order. And then just use the direction of the inequality. It points to the 2, opens to the x. Here it points to the x, opens to the 3. So you can rewrite your inequality and reorder the terms this way, giving you the interval notation, which would be a lower limit of 2, upper limit of 3, and again, parentheses or brackets. Parentheses. So this would be our interval notation for that.